Okay, in this video I'll go over factorials. Okay, that's when you see an exclamation point in math. I know for some of you that's different. There is usually a button if you have a scientific calculator on there. If you take your iPhone and you turn it sideways and it opens up to the large calculator, you'll see it. Okay, so if you have 5 factorial, that just means to take 5 times 4 times 3 times 2 times 1. And so if you multiply those, this is 20. 20 times 3 is 60. 60 times 2 is 120, and 120 times 1 is still 120. So that's what 5 factorial means. Now in the example problems, you end up having to simplify these, okay, or they say evaluate. So they want you to find the value of. So if I had 7 factorial over 5 factorial, I could write it out, and that would be 7 times 6 times 5 times 4 times 3 times 2 times 1 in the numerator. The denominator is 5 factorial, so that's 5 times 4 times 3 times 2 times 1. And so you're going to have a bunch of divisions. So 5 divided by 5 is 1, and 4 divided by 4 is 1, and 3 divided by 3 is 1, 2 divided by 2 is 1, and of course 1 divided by 1 is 1. So these all divide out to 1, and you're left with 7 times 6, and 7 times 6 is 42. So we can think of it when we're evaluating a factorial expression. We can realize that, okay, if this is 5 factorial and this is 7 factorial, and 7 factorial means 7 times 6, then what is written past that is 5 factorial. And so then those would divide out, and all I would be left with was the 7 and the 6. So let's practice another one using the shortcut instead of writing it all the way out. So suppose I had to evaluate 10 factorial over 8 factorial. Okay, so I know that 8 factorial is 8, 7, 6, 5, 4, 3, 2, 1, and 10 factorial is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So from 8 on, it's going to divide out. So I don't really have to write all those out. I'll know that once this 8 factorial divides out with 8 down, then all I'm left with is 10 times 9, and 10 times 9 is 90. So 10 factorial over 8 factorial is going to be equal to 90. So the next question is, what happens if I have a bigger number on the bottom and a smaller number on the top? So you've kind of seen this before in some of your other work. Okay, so suppose I had, let's say, 13 factorial over 15 factorial. Okay, so this one is 13, 12, 11, 10, 9, and so on. 15, 14, 13, 12, 11, 10, 9, and so on. So the 13 down is going to cancel, right? It's going to divide out. So all I'm going to be left with is a 15 and a 14. So just like before when we talked about having your polynomials, you know, if you had a lower power on the top and a higher power on the bottom, your leftovers would be on the denominator. So here, the 13, 12, 11 are all going to divide to 1, and in the denominator I'd have the 15 and the 14 left, and so then I just have to multiply 15 times 14, and that's 210, so I would get 1 over 210. Okay, let's do one more example. Suppose that I had several. Suppose that I had 8 factorial over 7 factorial, or times 7 factorial over 9 factorial 5 factorial. Well, what you can do here is use this same concept of what I was going to divide out, and you can take these and break them apart. So I'm going to work with the 8 factorial over 9 factorial first, and I know that 8 down is going to divide out, right? And so that's going to leave me with just the 9 in the denominator, because 8 down is going to divide out. And then with the 7 factorial and the 5 factorial, well, I know 5 factorial down is going to divide out, so this is going to divide out with 5, 4, 3, 2, 1, so that's going to leave me with just 7 times 6. And so my numerator is going to be 42, and my denominator is going to be 9. But I know that I always have to simplify, so I divide these. I know that 3 goes into both. So 42 divided by 3 is 14, and 9 divided by 3 is 3. So this would give me 14 over 3.